Welcome to the dynamic crust, also known as plate tectonics. We have now completed the unit on weathering, erosion, and deposition, and now we are moving on to the Earth itself, going underneath. So, a couple things, a couple of layers that you need to know. I'm going to go through this pretty quick because the reference table is going to give you a lot of this information. So the crust is the outermost layer. If you tap your feet down right now, you are tapping on the crust, also known as the continental crust. It varies. The crust itself varies from like 5 kilometers all the way down to 5 kilometers thick to 60 kilometers thick. Mountain ranges are really, really thick, where under the ocean is much, much thinner. The oceanic crust is under layers of marine sediment. It is composed mostly of basalt, and I'll show you that in the reference table, and it is more dense. The continental crust is made up of granite, and it is less dense. The moho is a thin layer or interface between the crust and mantle. The mantle is a layer below the moho. It is very, very large. It extends to a depth of 2,900 kilometers and includes most of the volume of Earth. Outer core is thought to be liquid, and that'll show you in the reference table as well how that works. But liquid, melted rock. S waves cannot go through it. We're going to talk more about waves when we talk about earthquakes. The S wave cannot go through liquid. So when an S wave uh, goes through the Earth, it stops or is absorbed at the outer core. Now, this is crazy. The inner core is hotter than the outer core, but considered solid. Now, why? Obviously, with the PowerPoint this way, it tells you right there. Typically, I would talk to you about it in class. The pressure is much greater the deeper you go into the Earth. Therefore, it keeps it in a solid phase, even though it is hotter and made up of the same material as the outer core. Now, here is the reference table. There is a lot of information in this. If you look, we're going to start up top here. And as I was saying, what the layers were made up of, see, continental crust, granite, oceanic crust, basalt. Right below that is the moho. Now, if you look here, we're actually looking at Earth's surface all the way down to the center, the inner core. So you'll notice here you've got the crust. Right below the crust is the rigid mantle. Then you have the asthenosphere, which is what we call the plastic mantle, stiffer mantle, outer core, inner core. If you look over here, it gives you the densities of these layers. 2.7 for granite, continental, 3.0 for basaltic, oceanic, 3.4 to 5.6 for the mantle. 3.4 is going to be on the high end. And as you get deeper in, lower in, it's going to become more dense. You're at 5.6. Outer core, 9.9 to 12.2. Inner core, 12.8 to 13.1. Now, what I want to show you is the bottom next. If you look down here, we have Earth's surface and the depth. The deeper you go, the layers get deeper here. So they're lining up this way. Now, so it tells you the depth, but now it's also telling you the thickness. You know that you could say, all right, the stiffer mantle starting about, I'd say 700, maybe 800, maybe 700, 700, all the way to 2,900. Okay, the outer core starts about 2,900 and goes all the way to 5,100 kilometers thick. Well, I'm sorry, deep. But if you subtract those two,